So now we're going to move on and do this by elimination. And most people tend to like elimination better. And all this entails is you want to add the equations together. The key thing being you need to have one of your coefficients so that when they add together you'll get 0. So notice in our case we have a positive 3y and a negative 3y. When we add these two equations together, we'll have 7x, 0y is here, and negative 7 plus 7 is also 0. Solving this for x, we'll get our x is 0. And now that we have our x value, we find our y the same way we did before by just substituting this into one of our two equations. Four times 0 is 0. So there's our answer. However, we still need to check. So we'll have 4 times 0 plus 3 times negative 7 thirds equals negative 7. 4 times 0 is 0. These 3's will cancel. So it works in the first one. Trying into the second one, three times 0 is 0. These 3's will cancel. A negative times a negative is a positive. So it works. So here's our answer. Now notice our x coefficients are at least similar. They both have a 2, but we need them to be opposite of each other. So how we can take care of that is just multiply one of the equations by negative 1. So then our first equation is still going to stay the same. Our second equation, multiplying that negative 1 by everything. Now notice the x's have those opposite coefficients. So now when we add our two equations, those will go to 0. 1y plus 5y is 6y. 7 plus negative 3 is 4. When we divide both sides by 6, we can simplify and get 2/3. And then we'll go ahead and substitute this into one of the equations. Once again, it doesn't matter. I'm going to go with the first one. It'll probably help to get that into a mixed number. Remember when we divide by 2, that's the same thing as multiplying by a half. So we'll get 19 over 6. So we'll get our answer. But once again, let's check it before we circle. And 21 divided by 3 is 7. And 9 divided by 3 is 3. So it checks. So here's our answer. Now notice, none of our coefficients are the same. And so what we need to do is multiply one of the equations by a number, or both of the equations by a number, to get our coefficients to be the same number, one positive, one negative. So notice we could multiply the second equation by 2, and then we'll get our y's to match up. So our first equation will say, our second equation becomes 4x minus 2y equals negative 14. So remember that 2 gets distributed to everything. Now notice our y's are opposite, so we can add them. And we'll get x equals negative 2. Now we have to figure out our y. But once again, we've got to check our answer. Works, so that is our answer. Alright, once again, solve by elimination. We have fractions, but think back to chapter 1. We can eliminate our fractions. And we can do this by multiplying by what would be our common denominator. So in this case, our common denominator would be 6. And actually in this case, it would be 6 as well. And so now, our equations would be so now at least these look a little easier. We don't have our fractions. However, we still don't have any coefficients that match up. So what we need to do is multiply both equations by a number to get our coefficients to even out. And it doesn't matter whether you want to work with the x's or the y's. I'm going to go ahead and work with the x's. And notice we can get our x's to 24. So let's multiply this by 3. This one by a negative 8. And we'll get 24x plus 9y so we'll have our two equations. Now notice our x's here are opposites, so we can go ahead and just add our equations. So our x's go away. So we'll get y's 2. And we still have to get our x. And so I'm going to go ahead and plug this in for y. Our 4's will cancel. We're left with negative 3. Remember, though, we do need to check our work. Negative 4 plus 1 is negative 3. This one we'd have to multiply by 3 over 3, so we get negative 9. This one by 2 over 2, which is negative 1/6. So there's our answer. Alright, now, once again, we're going to solve the system with elimination or substitution. Notice it doesn't tell us which way to use it. Notice, though, we already have variables by themselves, so substitution is going to be your best bet. And it doesn't matter which one you substitute into the other. So I'm going to go ahead and just substitute this one in for the y in the first equation. Notice on these first two, those negative 5 halves times negative 2 fifths just gives us 1x. And now if we combine these, we can do 5 over 1. So our common denominator here would be 2. We'll have negative 15 over 2. Subtract our x. We'll get 0 equals negative 15 halves. Well, 0 doesn't equal negative 15 halves. So what this tells us is there is no solution. So this means the lines don't intersect anywhere. Keep in mind, once again, though, if we had gotten a true statement,